So, environmental science. In this lecture, we'll talk about what environmental science is all about. I like this quote. In every deliberation, we must consider our impact on the next 7 generations from the Iroquois Confederacy. We haven't been doing that, and it's starting to show. So, here's our first case study we're going to introduce and then get back to later. Yosemite National Park in California. It's right here. It's a national park directly east of San Francisco, and it was created in 1890. So the San Francisco earthquake. The city of San Francisco experienced a tremendous population boom in the 19th century due to the gold rush. Grew really quickly. And in 1906, there was a powerful earthquake, followed by a devastating fire. So you can see pictures there. The city's water pipes were so damaged by the earthquake that firefighters were not able to tap the fire hydrants to put out the fires. As the city rebuilt, planners began looking for ways to address some of the issues with the city's infrastructure, including the water supply. And so the city applied to the federal government to construct a reservoir in the Hetch Hetchy Valley of Yosemite National Park. This is what it used to look like. An act of Congress and President Woodrow Wilson's approval were needed for the dam and the reservoir to be constructed. So we're going to talk about environmental science, and we'll get back to that case study and see what they decided to do. So environmental science is the study of the interaction of humans with the natural environment. So how does the environment work, and how do we affect that? Includes all the conditions that surround living organisms, that's the environment. Things like climate, air and water quality, soil and landforms, presence of other living things. And if you look at this chart, you can see some of the different things that are included in environmental science. Everything from biology to oceanography, anthropology, the study of humans, history, political science, of all things, economics, ethics. Lots of very diverse subjects. So, environmental science and the issues that it studies are complex and interdisciplinary. It covers lots of different topics. Concepts and ideas from multiple fields of study, and decisions have impacts in all of these fields of study. So here's an example. Say a community decides to use coal for electricity, as it is the cheapest source available. Currently, we get our electricity from coal, and the coal from a mine right near the power plant. So this community decides on coal because it's cheapest. This is not the case anymore. We're going to talk about that natural gas has actually outcompeted coal, and coal is not doing very well in the United States. So the coal must be mined from under the soil. That's geology. Then the coal must be transported to the population center by road or rail. That's engineering. When it's burned at a power plant, air pollution is released. Some of that pollution is converted to acid in the atmosphere. That's chemistry. This falls as acid rain somewhere downwind. Meteorology, study of weather. The acid stresses plants by affecting their nutrient absorption. Ecology. Laws are passed requiring the plant to install pollution scrubbers. Politics. All of this is environmental science. So, some of the major environmental problems that we'll be talking about this year. Resource depletion. So, natural resources are substances and energy sources needed for survival. And we'll talk about the different kinds. There's renewable resources like wind and sun, and non-renewable like coal and oil. So one of the biggest issues facing us right now is the fact that there are a lot of us. There's a lot of resources needed to support the human population. Every year I do this, I have to change this number because it changes so quickly. 7.7 billion people. Just to give you an idea how fast it's changing, the population has more than doubled in my lifetime, if you can imagine that. Renewable resources can be replenished within a human lifetime. Non-renewable resources is replenished extremely slowly, if at all, and they can be used up. The coal and oil that we're using was made millions of years ago, stored underground, and it will take millions of more years to make more. So once we're out for millions of years. So here's the world population. We're going to be talking a lot about this. A lot of things that we'll be talking about is this, they call it a hockey stick graph, because it goes along pretty normal and then it shoots up. And if you'll notice how much it's increased just in this span from 1950 to 2019 in this graph. And this shows you the distribution. A lot of it in Asia. Asia is a very big place. Africa is growing very quickly. Europe and North America aren't growing quite as fast, and we'll talk about why that is. Latin America is growing. Oceania is that very small area. Let's get an idea exactly how fast the population has been growing. So this is a population clock that is relatively accurate at the moment. And you can see, especially on the world population, how there's that each one of those numbers going up is a new person being added to the population. That's kind of mind-boggling, isn't it? Here's the US population, not nearly as fast because it's just the United States, but still, there's a new person added. While I'm talking to you, several new people will be added. So there's one birth every 8 seconds in the United States, a death every 12 seconds. So you see we get a new person. We're getting more new people than we're losing. We're getting one international immigrant or migrant for every 47 seconds. So that leads us to a net gain of one person every 16 seconds. That's hard to wrap your head around. And look at this again, the world population. Each one of those is a new child being born. It's really hard to imagine. Okay, so for an example of a non-renewable resource, coal. Over time it will become more difficult and expensive to extract. Here's the world coal reserves. Globally, there's about 861 billion tons. The United States is doing pretty good with coal. We have a lot of coal. And we're going to talk about why we're not using it as much anymore. Coal is kind of going away. Some of it's because natural gas has become cheaper. Some of it's because coal is a very dirty fuel. It's dangerous and destructive to mine it. There's lots of problems with coal. So this graph represents world coal reserves as of 2008. It's estimated in 2008 it's going to be different now because we're not using it as much. But at 2008 levels, when coal was the biggest energy source, we had about 250 years of the resource remaining at current rates of use. It's going to be more now because, like I said, we're using it less. Other major environmental problems. Pollution. Pollution is a degradation or undesired change in air, water, or soil that affects the health of living things. This is what you typically think about pollution: water bottles, plastic bags. This is showing what goes in the ocean goes in you, and it's showing you sushi made out of trash. Biodegradable pollution will break down naturally over time. So biodegradable pollution, it's not as bad. So paper breaks down, goes back into the environment. If you throw an apple core out into a park, it looks dirty, it's kind of nasty, but it's going to break down and fertilize the grass. It's not as big a deal as plastic, which may be around for hundreds or thousands of years. Non-degradable pollution does not break down. Like I said, some plastic will last in excess of thousands of years. Nuclear pollution. Some nuclear waste, radioactive waste, can last for hundreds of thousands of years. Pollution, whether it's in air or water, can move and affect ecosystems far away from the source. This map shows the areas with the highest concentrations of air pollution in the US. And let's see if we can look at a live one. And let's just look right here. Our air quality, probably because of all of the smoke, is moderate. It says if you're unusually sensitive to ozone, consider reducing your outdoor activities or shorten the amount of time you're outdoors. And like I said, that is probably because of the smoke. You can see for New Mexico, the yellow is the moderate. It's really bad up here near Denver. Again, probably because of fires. We're in this area right here. So another major environmental problem is loss of biodiversity. The number of species on the Earth is unknown, but estimated to be in the tens of millions. Biodiversity is a number of different species present in one specific ecosystem. Coral reefs have a very high biodiversity. Deserts have a relatively low biodiversity. Extinction, or the complete loss of a species, is a natural event that can be accelerated by human actions. Organisms have been going extinct for a long time. Over 99% of all the organisms that have ever lived are extinct. But it usually happens much slower than we're causing it to happen. Here's the population index for different organisms, and you can see all of them pretty much are decreasing. Loss of biodiversity. There are 5 known major extinction events in Earth's history, and this shows you them. Kind of an animation showing the different ones. The most recent major extinction was about 65 million years ago. It caused 75% of all species to disappear from the Earth. And here they are. Let's see. This one lasted about 10 million years. This was about 510 million years ago, the end of the Ordovician period. A lot of trilobites went extinct, a lot of marine species, 85% of the marine species. The late Devonian period, there's another extinction. This was about 363 million years ago. 83% of the marine species went extinct. End of the Permian. 95% of the marine species went extinct. The end of the Triassic, not as bad, only about 80% of marine species went extinct. And this is the one that you hear about the most, 65 million years ago, the end of the Cretaceous period. 76% of marine species went extinct, 47% of the genera, the genuses, disappeared and made room for us. All of the non-avian dinosaurs became extinct. That particular one is believed to be caused by an asteroid impact. Okay, so can you imagine? This struck in the Yucatan Peninsula, the Central America, and within minutes, 3/4 of North America was on fire. That's crazy to think about. Anyway, so let's talk about loss of biodiversity. Assuming that there's no catastrophic events, extinctions normally occur at a pretty slow rate called the background rate. For mammals, it's about 1 extinction on the planet every 200 years. Scientists believe we may be in the midst of the next major extinction event, and it's not caused by a meteor or volcanoes, it's caused by us. This is the background extinction rate. This is the extinction rate for different groups. There's mammals, birds, and amphibians, and some of the other vertebrates. Why do organisms go extinct? Some are very prone to extinction if they have a low reproductive rate or a specialized niche, which we'll talk about more. They're only found in certain areas, feed at a high trophic level, so apex predators. Fixed migratory patterns like blue whales, whooping cranes, and sea turtles. There's not very many of them. Some of the African violets and orchids. Commercially valuable. A lot of organisms like rhinos and elephants that are endangered, it's because their parts are very, very expensive. And large territories, California condor, grizzly bear, Florida panther, they can't live in a vacant lot in a neighborhood. They need sometimes tens or hundreds of square miles to survive. So Australia has experienced 27 mammal extinctions since 1788, probably due to the influence of European settlers. Not so much the people are going in there and killing them, but we bring a lot of other stuff. Australia has a huge problem with invasive species, rats, frogs, rabbits, and they outcompete the things that were there originally. Here's an example of a extinction event that happened relatively recently. It was discovered by Europeans in 1741, Steller's sea cow in the Bering Sea between Alaska and Russia. This was like a manatee that you see in the videos in Florida, very cute, very slow, happy looking face and everything. This thing was way bigger and way slower and probably couldn't dive. 27 years after Europeans discovered it, it was hunted to extinction. 27 years between its discovery and it was wiped out. Okay, and we're going to go ahead and stop there, and we'll finish this up tomorrow.